Good morning. I know I freaked you out with all those practice tests. First off, maybe I'll make a note here, right? The practice tests should be called practice for test 1. And I know there's 3, don't worry, I don't do that again. It was at the beginning of last term when I was all full of spunk. And I was like, oh, they need to know how to do this, and they need to know how to do this. And then I'll give them more practice. And it just got a little out of hand. So this is the only time that I give you 3 practice tests, and they're actually practice for test 1. So I posted 3 versions of the practice test. Oops, I didn't even finish that word, test. Should be called practice for test 1. Keep doing that. Because it's way longer, right? And I think what you'll notice when you go through it, and I've got it here to pull up, but you'll notice that there are similar questions, right? Just giving you a little taste of different versions, just so you don't get hung up on a question being exactly a certain way, right? And so I wanted you to kind of expand your mind a little bit. Practice tests, oops, can't write it all today. Sorry, guys. You're my first class of the week, so you get the brunt of it. Practice tests are optional and not for marks. Although I will say, if I see a practice test with a nice high grade, I might use it for an assignment mark for you as an individual. So I'm saying they're optional, but if you've already spent the time and you've got a high grade in the practice test, I want to reward you for that. So then I might swap out maybe a lower assignment grade or something like that. But I'll do that at the end of the term, right? So just kind of keep that in mind. But only because I don't want you to feel like, oh, I did all that work and it was for nothing. Well, it was for practice. But they're optional, not for marks. They're just for you to practice. And don't worry, I don't go wild and crazy again. You'll just have 1 practice for the rest of the tests. Where was I? Here. Okay, so I've got version 1, version 2, version 3. If we have a look in version 1, I guess we'll pull up a kind of a nicer version here. Guess I shouldn't have the key, but we've covered all of this material, right? I did make a note in that email. I know it was a long email, so I don't blame you if you kind of skimmed through it and maybe didn't read this part, but the last few questions we haven't covered, we're going to save those for the next test. They're on lines, but everything up until question 34, you'll be able to do easily, or, you know, kind of with everything that we know. So 34, where are we here? 32, right? We talked about inequalities last day. You didn't get an email. Should have sent out as an announcement. I am assuming that you've got your email hooked up to Moodle so that it just forwards to your email. But yeah, check your junk mail. Yeah, weird. I did send out an email, right? Did anyone? Okay, so Okay. Okay, that's good. So I did do it. You had me worried there that I didn't. Oh, that's strange. Maybe, yeah. I didn't get any bounce backs or anything, but I don't know. Maybe it doesn't do that through middle. Anyways, yeah. So much for that now. Sorry. Okay, so we talked about inequalities last day. We're gonna finish inequalities. We talked about, and I don't have a pointer on the website, so you'll just kind of have to follow my voice. Right, so here we've got a linear inequality, but it's wrapped up on both sides, right? So that's where we kind of ended off last day. You have to manipulate both sides of the inequality, right? And so, and then of course, once you have an interval, you can graph it. So today, we talked about how to solve nonlinear inequalities, right? And question 34 and 35 and 36, but 35 and 36, they're just showing you different types of an absolute value question. So they're the ones that we have to cover still. Okay, so and then everything after, so 36 and then 37 onwards, although I think you'll find those questions are quite a bit easier than inequalities, for example. But we'll save that for nice little easy questions for test 2. So don't worry about 37 onwards. We'll save those. But now you have the practice for them. I'll kind of bring them back, but for test 2. But yeah. Good. So we have not covered section 1.10, which is on lines. So we will save question 37 to 42 for test number 2. Okay. So now question 34 is on nonlinear inequalities. Okay. Which we talked about, right? But we didn't do an example. So how about we just refresh our memories here. Okay, I'll bring this in and we'll talk about it some more. I guess there's no review today, so just jumping right back into inequalities. But in doing so, we will be kind of going through inequalities again, so not to worry. So what we do is we want to set our nonlinear inequality. We want it to be in terms of 0, just because 0 is the easiest thing to work with, right? Just like when we use the quadratic formula, we set it equal to 0 to see where it crosses the x-axis. So for most of these problems, we're just going to have quadratics, which we know how to deal with. Right, and so again, we're just going to set things equal to 0. So here, when they say move all terms to one side, that's what they mean, right? So set everything equal to 0 and see what happens. Then if it's not factored already, then you have to factor the non-zero side of the inequality. Just for kind of simplicity, and because it's we're kind of short on time, I'll give you a factored problem, right? So I'll give you something that's factored already, so you don't have to do that. Although you easily can, and you can go through those practice problems that are in the notes, right? And try try adding that extra step of, okay, I have to use the quadratic formula because I've got a quadratic that I need to factor, right? So for us, we're gonna not need to do this step because I'll give you something factored. Then we have to find the intervals, which involves finding where the zeros are, right? And then we'll use those as cutoff points. And then what we do is we make a table of values, and we're going to use this technique a couple of times throughout the course. So this is the first time that we're seeing it. It is going to be weird, okay? But once you have the hang of it, then it's going to be okay. So, and then we'll be able to use this table to actually solve the inequality. So let me grab some of these here. I'll make a note. On test number 1, I will give you a factored inequality. Right, so what I mean by that is something like 37, 38, even 39 and 40, right? So not 41 through 50, right? For practice, you can work through and you can factor something like this, right? But I'll give you something kind of easier, right? Here, 51 and 52, they're no longer quadratics because we have 3 x's in each of them. But because they're factored, we can still work with those, right? So what I want to do is let's go through something kind of like what I expect you to be able to do. So 37. So if we follow those steps, the guidelines that we had, right? First thing we have to do is we have to check to make sure that we have 0 on one side, right? So kind of step 1, all terms are on the left, right? So they're on one side, so that's good. So we don't need to do anything there. And maybe I should write down the problem first. It is x plus 2 times x minus 3. Where is it less than but not equal to 0? Okay. So all the terms are on the left, so all the terms are on one side. So that step is done. Step 2, factor. That's already done for us, right? So this is kind of the type of problem that I'm expecting you to do. So then step 3, we have to find the intervals. Oops, sorry. Find the intervals, which means, okay, where does this thing equal 0, right? And then we can use those intervals to see how it relates to being less than 0, right? And so this x plus 2 times x minus 3 will be 0 when x is negative 2 or when x is positive 3, right? So step 3, x plus 2 times x minus 3 equals 0, right? So even though we're interested in where is it strictly greater than 0, in order to have a jumping off point, we need to figure out, okay, where is it equal to 0? And then we go from there, okay? So is equal to 0 at x equals negative 2 and x equals positive 3. Okay. So then what I want to do is, okay, so if you expand this out, this is a quadratic, right? So you know it's going to have this parabolic shape. It might be facing up, facing down, right? And so, oh, and now I have this vague memory that we went through and drew one in Desmos at the end of last day. Phew, it's the same one. Okay, so we went through and we already graphed it in Desmos, and so we saw this behavior, right? In fact, I don't want to bring it over, not yet. We'll bring it over to confirm our answer later on. How about? Okay. But so we know the behavior from graphing it. We know it's going to look something like this. And so at -2 and at +3, it crosses the x-axis. So now step 4, make a table. So what does that look like? Okay, so what I'm going to do is I'm going to draw a number line and kind of midway here. You don't have to worry about the spacings making sense. It's just to visualize the breakup points here. So you've got -2 and 3. So you're going to jot those down from step 3, right? X equals -2 and x equals +3. I'll just kind of map those on here. Okay, so that's where those came from. Yes, you can change the inequality to an equal sign, but only because we're trying to figure out where it crosses the x-axis. And then we're going to use those to figure out where is it less than 0. So where is this thing below the x-axis? Right. So what I want to do is we only need to know the sign, right? We only need to know if this thing overall is positive or negative, right? If it's positive, then you're above the x-axis, right? If it's negative, then you're below the x-axis. Okay. So what we're going to do, and this is going to feel weird in the beginning, okay? But what we need to remember is that this equation is going to behave the exact same for all values less than -2. Okay, we know at -2 it is 0, right? And we know at 3 it is 0. So we're not interested in those points exactly. We're interested in points kind of in each of these regions. Okay, so what we're going to do is we're going to draw out our expression, right? X + 2 times x - 3. And we're going to do it in each of these regions that we have. Okay, so that's why I'm kind of scooting it all the way over. And I want you to kind of imagine you've got your page broken up at each of these points. Because what we're going to do is we're going to do the same thing 3 times, right? So I'm showing you over here, and then we'll move over to the next region, and we'll show how to do it there. But we do the same thing, and then we do it again in the next region. Okay. So what we do is we pick some test point. Okay, we call it a test value, and so here I'm going to pick a convenient value anywhere, any value less than -2, right? Because like we said, we already know how it behaves at -2. So something to represent this region. And I would just pick easy values to deal with, right? And so here, let's pretend that this is at, I don't know, -4. Right? And I'll just make a note here. Pick any value less than -2. Okay, And then over here, we would pick any value between -2 and 3. My go-to is going to be 0, right? If I can do 0, then I will. And then in this region, we're going to pick any value that's greater than 3. Now, what happens is you don't even need to pick a certain value. You just need to figure out if this is going to be positive or negative for values less than -2, right? But the easiest way for me, at least, to do that is to pick a value and then see if it's positive or negative. So what happens is I'm going to have, so this becomes -4 plus 2 times -4 minus 3. Now, here's the thing. We don't need to figure out the exact value, okay? We only need the sign. We don't need the value, just the sign, right? If it's positive or negative. So here, I know I have -4 plus 2, that's a negative number. And then I'm multiplying it by a -4 minus 3, that's also a negative number. So how we show this is we say, okay, well, I've got a negative times a negative equals a positive, right? What that tells me, okay, is that, okay, in this region, up until, so from -infinity up until -2, I'm going to be above the x-axis, okay? Therefore, from -infinity to -2, we are above the x-axis. Okay, so we don't care, exactly what the values are, right? But now we've figured out that we are positive, and so here, right, we know at -2 we're 0. So what we have is we kind of have this situation, right? We're above the x-axis, approaching -2, which is where we cross over to a negative. Okay. I don't want you to assume that it's going to be negative below the x-axis here, because sometimes it'll just bounce off again, right? So we have to check each region. But now what we do is I'm going to go a little bit faster, right? And so I'm not going to plug in these values. I'm going to go straight from here, our original equation, down to the sign, okay? And in my mind, I might use a value like 0. Okay. So here's what your actual work would look like. So x plus 2 times x minus 3 is the same as, so now you can pick any value between -2 and 3, but for me, the easiest one would be 0. So now I just imagine 0 plus 2 is positive, and 0 minus 3 is negative. A positive times a negative is negative. Okay, so here we found that we're below the x-axis. Okay, so what we have is something kind of like that, maybe. Because we know that at 3, again, we're at 0. So what could happen is it could bounce back down, right, at 3. In this case, it's not going to, right? But so we know that this is kind of what it looks like. And maybe I should use dotted lines here too. There. Okay. So now we'll do the same thing for the third region, and just maybe in my mind I use 5, anything greater than 3. Or if you just want to think about just any value greater than 3, you don't have to pick a specific value, right? Then x plus 2, if x is greater than 3, then this is positive, right? Just kind of doing it double time here. And then x minus 3, as long as x is greater than 3, it's also positive, which a positive times a positive makes a positive. So all you really need to show right here, all this light blue stuff, that's just me explaining. This is the only work that you need to show. Okay? So I've kind of whittled it down to, so from a big explanation to kind of less, and then in the end, this is what you need to show. Okay? So, and you don't even need to pick test values, like I said, those are optional. Okay? But I do find that they're a useful crutch sometimes if you're having troubles. Okay. So now what do we do? Step 5 says solve. Okay, well, oh, sorry. I don't know why it's turned so laggy. I don't remember it being laggy at the beginning of the term, but whatever. So now we need to actually figure out what the solution is to our particular problem. We wanted to know where this thing was less than but not equal to 0. Okay, so now I know that, okay, well, it's less than but not equal to 0 at all values between -2 and 3, but not including -3, or not including those endpoints. So step 5, solve. We see that x plus 2 times x minus 3 is less than 0, right, but not equal to 0. And that can change, right? So sometimes we include those endpoints, sometimes we don't. On -2 to 3, right, in interval notation. So when x is between -2 and 3, that's when it's going to be less than 0. Okay. So that's how you do one of these nonlinear inequalities. And I know that they're tricky, but you do have those steps to follow, right? And you're going to follow those steps every time. So now, what if we wanted to know where it's greater than 0, right? So if we started a new question and we wanted to know, okay, where is it greater than 0? Then we would have to link up those regions, right? We know how to use interval notation. Well, we decided that it's positive, so greater than 0, right? Remember, positive is telling me, okay, larger than 0. Negative tells me that it's less than 0, right? So if I wanted to know where it's greater than 0, well, that would be the interval from -∞ up until -2, but not including -2. And then we join it with a union, and then we pick it up at 3 again, so from 3 until infinity, but not including 3. Right? So just kind of be prepared for kind of multiple regions being linked up. Let's see if I can. So I'll keep it to, I just want to go back and make sure. So 34 on your practice test version 1, but they're all kind of the same, right? Notice that you've got, and your numbers will be slightly different, right? But if we wanted to do x minus 4 times x plus 8, where is it greater than or equal to 0? Then you would include those endpoints. So maybe what we'll do is, instead of doing 51, because I was going to do 51, how about we just do this one together? So let's do, from the practice test, question 34, a version of it, because we'll all have different numbers, or kind of slightly different numbers. So practice test version 1, question 34. Right. Numbers might be different. The idea stays the same. Okay. I had, now let me see here. X minus 4 times x plus 5. Why did I say 5? I think it was 8. I don't know why I said 5. It's 8. X plus 8. It doesn't matter. Or is it greater than or equal to 0? Okay. All right. So now we want to know, right? What does this tell us? Well, now we want to know, where is this thing above the x-axis, right? Oh, and sorry, before we move on from here, right, I will say that from last day, when we graph this in Desmos, copy. I'm gonna just make it smaller here. There. All right. So you can always use Desmos to check your work, right? If you're saying that it's less than 0 between -2 and 3, right, that should match up with the graph that you have in Desmos, right? So, I mean, because the test is open book, you're allowed to use all your resources, you're not allowed to work together. And as long as what you're telling me is your own thought process, right, that's a good rule of thumb, then you're allowed to use all your resources. So you're allowed to use Desmos. You can have any calculator you want. You can have your notes available, right? So just make sure that you're working alone. That's the only restriction. And then, so definitely use Desmos to check your work, right? But I do need to see your work, right? Where you're constructing a table like this. Right? But at least if you graph it first, then you know what to expect, right? So then you can kind of work towards that. I'm not saying that that's great, but I do it all the time, right? So, oh yeah, you should be able to just ignore the inequality. If you just graph the left-hand side, and you should just be able to put it in the way it is, but I'll do it for this one too. In fact, maybe that's a good place to start, just so we feel a little bit more confident about where we're headed, right? So, all right. So I'll put it as step 0. Step 0. Graph x minus 4 times x plus 8 in Desmos to get an idea of the answer. All right, just to kind of see what we're expecting, and then we can kind of work towards that. All right, so I'm going to go into, oh, that's something else. Okay. And I'm just going to plug it in exactly like it is, and we'll see how that works. So x plus 4 or minus 4? minus 4 plus 8. One day I'll get it. X minus 4. Oops. Hey. X minus 4, end bracket, times x plus 8. Hopefully I did that. Hopefully that's the one. So here, just looking at where do we expect this thing to cross the x-axis? Well, I'm expecting it to cross at x equals -8, right? And x equals +4, which we can confirm there. Okay, and if we zoom out, right, it's kind of a long one. Woo. It looks like it's above the x-axis. Oh, so what happens is when we add the inequality, where is it less than, I think it's less than or equal to 0? It only tells you the region, which is the answer, right? But it's not very useful for visualizing. So if you ignore the inequality, then we can decide which region we want. But if you add in the inequality, it tells you the region of the answer. Right? So here, right, we can tell that we're going to be above the x-axis from -infinity to -8, and then below from -8 to 4, and then above again from 4 till +infinity. Even though it doesn't look like it, those arms go all the way to infinity in either direction. So, all right. So we graphed it, and we found that it kind of looks like this right here. This is at -8, 0, and this is at 4, 0. And so we want to know, oh, sorry, greater than or equal to 8, or sorry, 0. I don't know, I can't talk today. So let's try greater than or equal to 0. So it shades 2 regions, and so our answer should have an interval linked up with another interval. Okay. All right. So from just the graph, I could answer the WebAssign question, right? But I'll be checking your work. You have to submit your work, and I think I sent it out in the announcement. So as you're doing your work on WebAssign, you're going to have probably just paper, right? So do all your questions on paper. Question 1, question 2, just from WebAssign. And then when you're finished, you're going to scan that work and upload it to me, okay, on Moodle. I'll give you an extra 10 minutes after the quiz closes to upload it, but make sure that's not a lot of time at the end of the day. So so make sure that you're quick at scanning, and if there's a lot of scribbles, that's totally fine. The reason there's 2 reasons, right? One is I want to make sure that you're doing work and that it's kind of reasonable. But the second reason, and this is more for you guys, definitely more for you guys, is I've had in the past where people spend time doing a quiz and then for some reason their answers are lost. So this is your record of the answers that you have given to WebAssign. So at least if you have them written down, yeah, so the test is on WebAssign. Just like the practice test, just shorter. So when you're doing the practice test, practice doing that, right? Practice, so question 1, ideally you'll do them in order, but not necessarily, right? So, and even if it's just an answer, right? Maybe just jot down what the answer that you chose is, just as a record of what answers you've put in. Right, and then if something happens, then I can always go back and say, oh, okay, well, they did say this here, so then I can give you the marks if they're missing. Okay, so so it's really just for you to have a record of what answers you put into WebAssign. That's the most important thing to me at this point. But also I need to check your work and make sure you're actually doing stuff. Okay. For test 1, the majority of your grade will be from just WebAssign. But I will put some weight on the work. So if you don't give me any work, I can't give you any marks. Okay. So, cool. So here we go. Yeah, so make sure you have a scanning app that you like, that you know how to use, and that you're able to save it as a PDF. It has to be one PDF, just a single PDF. You should be able to do it. But if you need help, then definitely let me know. I have an iPhone and I use Scannable all the time. Scannable is really good for iPhone, but I think it's an iPhone only. I know Cam Scanner is really popular. So just try them out. When I was first kind of figuring this stuff out, I just downloaded a bunch of free scanning apps and figured out which one I liked best when I got rid of the other ones. So you can do the same. Okay, so now we already know oh, nice. Yeah, that's totally fine. So if you have a printer and you want to print out the actual test and then do the work in the spaces, that's great. Yeah, easy peasy. Then you can scan it and upload it and be done. That's great. But I don't want to assume that people have a printer. It's just printers. But yeah, that's probably the easiest thing to do. All right, so old school or new school, eventually we'll all have printers again, just because it's easier. Okay, I keep getting sidetracked, but it's good. So here, where is it greater than or equal to 0? It's greater than or equal to 0 from -infinity up until and including -8, right? Because we want equal to 0. And then we pick up again from 4 till +infinity, including 4. So we know the answer already. And if you're tight for time, you could put that into WebAssign because that's the answer, right? But we need to show all our work. Is that backwards? Do you mean the inequality? Did I copy it down backwards? X - 4 and X + 8. Uh-oh. What have I done? Nope, looks the same to me.
On the, like when you're doing that little pretend Desmos thing, you have it as -8041. So you just go backwards? Because you got X minus, okay.
What we'll do, so we'll do it in the actual steps, but we're going to find that when X is +4, right, which maps to here, that's when it's equal to 0. And when X is -8, it maps to 0. Yeah. So I guess it is a little bit backwards, but it's where it crosses the x-axis. Sorry, I've got to sneeze and it just won't come out. Sorry. Oh, okay. So, but we'll see that in step, I don't know, 3. So now let's do step 1. Step 1 was move everything to one side. That's already done. And like I said, right, this is a question that you can expect kind of this level of difficulty is what you should expect for the test. Right? Step 2, factor, that's already been done, right? Same thing, right? I'm not expecting you to factor. There's a lump of questions where you have to use the quadratic formula on the practice test. So I'm going to go ahead and say you've had enough practice with the quadratic formula. We don't need to use it again to factor, but yeah. All right. Step 3 is find the intervals. So what we do is we set x minus 4 times x plus 8. We set it equal to 0 to find those cutoff points. So x, yeah. So here, I'll say x equals positive 4, makes this term 0, right? And then here, x equals negative 8 makes it equal to 0. So those are the points on the x-axis, which we actually already knew, right, from Desmos. But that's where it's coming from mathematically. Okay. So now, right, in step 4, I can make a table. And this is where I draw just the number line. It is the x-axis, but I just ignore the y-axis. And then what I'm going to do is I'm going to have negative 8 and 4. Again, spacing doesn't matter. It's just to visualize. So I want to break it up because I know I have to do a little bit of math in each region. So I want to have kind of the same amount of space in each region. And just to kind of break it up visually here, I'm just going to kind of break up the spaces. So I'm going to, well, first of all, I'm going to bump this up because I don't want to run out of space later. Bump it up 1 line. Because my page ends here, so running out of space. Okay, but then what I want to do is I'm not going to do all that explaining that we did in the previous question. I'm just going to go ahead and do exactly what you would be doing on the test. Okay, so here, this x equals negative 8 went here, and this x equals 4 went over here. Number line, you have to have them in order, right? Otherwise, it doesn't make sense. So all you would be expected to do here is say, okay, x minus 4, right? We do our times x plus 8. Okay. You can pick a test value, okay? But what I'm going to do is I'm not even going to do that, just to show you kind of the bare minimum of what kind of work you need to do, right? I'm just going to pick a value less than negative 8, let's say negative 10, and then just kind of go through what would that be? So negative 10 minus 4, that's a negative number. Negative 10 plus 8 would still be a negative number. So a negative times a negative makes a positive. And usually I circle it just to kind of highlight. Okay. So up from negative infinity to negative 8, it's going to behave the same, and it's all going to be above the x-axis. It's going to be greater than 0. That jives with the graph that we started with, right? In our pretend step 0, we added that step, which is just meant to kind of boost your confidence, right? And so you already know the answer. Let's just kind of get there, right? Above the x-axis, that's exactly what we were expecting, right? So no surprises here. I'm going to move on to the next region, my favorite region where I have 0, right? 0 is easier to think about. So now I'm going to have x minus 4 times x plus 8. That's going to be 0 minus 4 is a negative number. A negative times a positive is a negative number, right? So it's kind of fun math that way because we only really need to know how, two negatives multiplied together make a positive. One negative times a positive makes a negative, right? So we don't need to do any math necessarily, although you can, right? If you did, if you had x equals 0, you'd have 0 minus 4. That's negative 4 times 8, which would be a negative number, right? And so that's where you would get that negative from, right? So whether you plug in values and check the sign of that value, or just kind of, I actually think it's easier to just look at the overall sign, but it's up to you. And then x minus 4 times x plus 8. Again, how does it behave? Now I'm at values greater than 4. Anything larger than 4 minus 4 is still going to be positive. And then, of course, anything larger than 4 plus 8 is also going to be positive. So because I want, where is this thing greater than or equal to 0? So step 5, and like I said, I'm dealing with a page break here. Step 5 is solve. We have x minus 4 times x plus 8. Where is it greater than or equal to 0? Right? So this thing is greater than or equal to 0. Well, it's equal to 0 at negative 8 and 4. So I'm going to include those endpoints, right? That's the difference between the question that we just did and this one. And then we want to know, where's this thing positive? Well, on negative infinity up until negative 8, including negative 8. Okay. And then I take a break, right? So I link these up with a U, the union, right, from the set notation that we learned very, very early on. And then I pick right back up at 4, but I'm allowed to equal 0. So at x equals 4, that's included up until positive infinity with a round bracket around it. That's it. Like I said, if you run out of time, you can just graph it in Desmos and put in the answer, and that's fine, right? But ideally, I want to see the work. If there's work kind of missing for that question, I'll kind of, all right. But sometimes, if you're running out of time or whatever, I get it. But try showing the work. But you have a way to answer the question without it. I know. I'm not supposed to say, but right, I can't say, oh, just use Desmos and don't do any work, right? But I also know that the test is this week, and this is a lot to wrap your head around. What's important is that we kind of keep this idea of making a table with the signs in mind for later sections, right? So even if you don't use it for this section, that's fine. But we need to have seen it and used it and kind of know what's going on. All right. I do want to talk about absolute value inequalities, but maybe we should take a 5-minute break. Need to caffeinate to get through some more inequalities. Yeah, right? Well, what just happened? Yeah. So let's be back here at 9. We'll pick it back up. That'll be my excuse. Well, I don't know. I'm assuming it was enough time. All right. So I know, I should have given you like a warning shot. Okay, go. Everyone start your kettles. Get set, go. All right. So for absolute value inequalities, they look bad, but they're not actually that bad if you just have the rules handy. So, okay, just had to make sure that I'm recording again. So here, this little blurb, you'll want to have handy for all these absolute value inequalities. After that, right, if you're able to translate the absolute value inequality into just a regular inequality, then we're back on easy street, right? So, oops, here, right, absolute value inequalities. If you have the absolute value of x is less than c, remember the absolute value in applications, we just drop the negative, right? But what's really happening with absolute value is if you have a negative number going into the absolute value, technically what it does is it makes it negative. So then you have a negative of a negative, which is what makes it positive, right? So what happens in terms of an inequality, right? You can translate this absolute value inequality into just a regular inequality, which we already saw last day, and we know how to deal with that, right? Same thing here. So if you're dealing with a less than inequality, then it's nice and easy. You just kind of wrap it around the positive and the negative version, right? Make more sense once we do an example. However, if you have a greater than, so whether that's greater than or equal to c, let's say some number c, it gets a little bit trickier because now you're kind of in two regions on your number line. So what happens is, okay, so if you have the absolute value of x is greater than c, then you're going to have two answers, right? X is less than negative c, or c is less than x. Okay, so a little bit weird, but as long as you have this little cutout, right, available and handy, then we can translate any inequality, any absolute value inequality, and then be able to calculate it just using just normal inequality rules. Just a reminder for inequalities when we're working with them, it's only when we're multiplying or dividing by a negative number that we have to switch the sign, right? So that's from last day. This is the one I want. Let's go through some problems, and then I also want to show you in the practice test. We'll do the ones from the practice test too, but first, let's do 79 just to get a kind of a handle on things. Okay. So what we do is we translate our inequality into, it's going to be one of these, right? So even though we don't just have the absolute value of x, here we have the absolute value of x minus 5. You're just going to use x minus 5 as your x, okay? And so what I mean by that is, okay, we map this. So I have an absolute value less than or equal to some value. This is the same as inequality 2, right? So 79. The absolute value of x minus 5 is less than or equal to 3. Right? And so I'll say looks like the absolute value of x is less than or equal to c, right, from the handout, which means that we can rewrite it. The equivalent form would be negative c is less than or equal to x, which is less than or equal to positive c. So negative c is less than or equal to x, which is less than or equal to positive c, right? So you just write out what the equivalent form is. And then what I want you to do is I want you to replace, okay, so in our case, our x is going to be replaced with x minus 5. So what I'm going to do below here in a different color, I'm going to write x minus 5 instead of x. The inequalities stay the same, right? And instead of c, I'm going to write 3. Right here, I'll have negative 3, and here I'll have positive 3. Okay, so you don't need to write out this step, but I do find that it makes kind of a nice chain link, right? So here we've got our question. I map it to whichever one it looks like, one of those 4 inequalities that I have on the handout. And then I write out the equivalent form, and then I just map my question into the equivalent form. So what we're trying to solve, right? The question says solve the absolute value inequality. I know when you're first getting started, solve is like solve what, right? But as soon as there's an x, we mean solve for x. Okay, so and then we want to express the answer using interval notation and then graph the solution. We're not going to graph it. I assume that you know how to map onto a number line already. So now we can solve this inequality, and I'm just going to write it out again. X minus 5 is less than or equal to 3. I know from last day, if I want just x in the middle here, right, I can add 5, but I have to add 5 to all 3 regions, right? So I get negative 3 plus 5. Oh, didn't write negative 3. I said negative 3, I didn't write negative 3. Negative 3 plus 5 is less than or equal to x minus 5 plus 5, which is less than or equal to 3 plus 5, right? As long as you're doing it to all 3 regions, you're allowed to do it. The only kind of problem is if you're multiplying or dividing by negative, then you have to switch the signs around. In this case, I'm just adding 5, so we're safe. Minus 5 plus 5, the whole goal was to get rid of that, and so I have done that. Negative 3 plus 5 puts me at 2, which is less than or equal to x, which is less than or equal to 3 plus 5, which is 8. So then my answer in interval notation, I'm including these endpoints, right? So I have to use square brackets. But there we go. Oh, rats. I think I'm getting a, shoot. Sorry, guys. Whenever my phone ring, it like undoes some stuff. Okay, I think we're back. Good. So our answer here, yeah. So only when you multiply or divide by a negative, that's the only time that it's going to switch the inequality. So you can subtract. So here we could have subtracted. That's safe, but it's multiplying or dividing that we have to switch it. Good. Okay. So how about we do, let's do another one for some more practice. Let's do a greater than one, because remember, the greater than inequalities, they're a little bit weird, right? Because we've got, it's going to be less than or equal to or less than the negative c, and then it's going to pick back up at positive c, right? And you can see what it looks like in terms of our graph, right? We're going to have these two regions, and so the greater than inequalities are a little bit weird, right? So let's do a greater than inequality. If I look at 84, so the absolute value of 8x plus 3 is greater than 12. If I have to map it to one of these three or one of these four, it would be number 3, right? And so this is the one that I'm gonna mimic and kind of fill in. I'm gonna do that same thing where I write out the question and then I write out the similar one with the equivalent form. Okay, so 84. I'll copy it from here. The absolute value of 8x plus 3 is greater than 12. And then in light blue, this is optional. Looks like, let's get this over. This looks like the absolute value of x is greater than c. Right. So from that, right, so now I'm going from the absolute value of x is greater than c. So x is less than negative c, or c is less than x. Okay, I'm just going to copy that out and then I'm going to map to it. So x is less than negative c, or c is less than x. As long as you have that little handout, you're safe, right? You can just jot them down. So in this case, wherever I see an x, right, in this equivalent form, I'm going to replace it with 8x plus 3. Wherever I see a c, I'm going to replace it with 12. Okay. So I get 8x plus 3 is less than negative 12, or, 12 is less than 8x plus 3. Okay. To solve each of these, I'm going to solve for x in both situations, right? So now I can solve. So I have 8x plus 3 is less than, negative 12. Don't forget that negative, make a mess. If I'm solving for x, first thing I have to do is I have to subtract 3 from both sides, right? Subtracting 3 is safe, so 8x is less than negative 12 minus 3. Negative 12 minus 3 is negative 15. To solve for x, I have to divide by 8 on both sides. Positive 8, that's safe, right? I'm allowed to do that. So x is less than negative 15 divided by 8. Just kind of doing two things at once. I'll move this over and I'll do them side by side, right? Or 12 is less than 8x plus 3. Yeah. Solving for x, again, I have to subtract 3 from both sides, and then I have to divide by 8. Positive 8 again, so I'm allowed to do that. I don't have to switch the sign. All right, so then I have 12 minus 3 is less than 8x. So then 12 minus 3 puts me at what, 9? 9 divided by 8 is less than x. Okay. I'll see if, I can't think of anything. Negative 15 divided by 8. It doesn't simplify to anything. 9 over 8 doesn't simplify to anything either. You don't have to simplify them. I as a teacher, I don't care about simplification. Some teachers are really hardcore about it, and you have to simplify. But I personally don't care too much. The numbers are the same, so it doesn't matter. But just as a heads up, if you start Calc 1 and you have someone who's really into simplifying, then you would have to check it. But then I would recommend that you have a calculator like this one, maybe, that does the simplification for you. Make it easy on yourself. Oh, oops, what happened here? Okay. So then here, right, it gets a little bit weird to think about. So x is less than negative 15 over 8, or x is greater than, right, reading it kind of wonky, x is greater than 9 over 8. Okay. So it's going to come from negative infinity. So here the answer in terms of our interval notation, from negative infinity up until negative 15 over 8, not including those endpoints, right? Because it's not less than or equal to, it's just less than. And that's going to come from the original problem, right? Whether it's greater than or equal to, or just greater than. And then we're going to pick right back up at 9 over 8 up to positive infinity, not including those endpoints again. Okay, good. So I would say, right, as long as you're able to identify which of those 4 inequalities you map to, then you write out the equivalent form, and then your math is going to be with that equivalent form, right? This form here. And then you'll be able to find the inequalities with respect to x. So now what I want to do is I want to go back to the practice test. I'll do version 1 again, because that's where I'm in here. 34, it's the nonlinear inequality. Okay, so 35 and 36 are 2 different absolute value inequalities. I'll just have, on the test there'll just be 1, right? But I wanted you to be able to practice both types, right? Here, sorry, I don't have a pointer, but here, the absolute value of 3x plus 4 is less than 5. Your numbers might be different. But this is a less than situation, right? And we'll go through and do it, but right, so then that's one of those easier ones. It's when we have greater than that we have 2 regions that we need to work with. And sure enough, 36 gives you practice with a greater than problem. Okay. So these are both very similar to what we just did. Right? So let's go through and do these. So I want to do number 35 first, and then 36. So practice test, question 35. I say it, and then let's see if I'm able to split the screen here. I have the absolute value of 3x plus 4 is less than 5. And then just for later, 36 is the absolute value of 3x minus 2 is greater than or equal to 5. Because now I can get rid of this. How do I? how sloppy that is. I'll rewrite it. That's for later. But I have the absolute value of 3x plus 4, just writing it. This is exceptionally sloppy when it's all zoomed out like that. Okay, this, right, I can map to one of those 4 situations, right? This looks like this one. Right? So for me, just to kind of follow the same method, I'm going to write this one out, and then I'm going to write out the equivalent form next to it, and then I'll plug in my values. If you just wanted to go straight to here with your values, totally fine, right? I am adding an extra step of work that you don't really need, but it works every time. So, okay. So this looks like the absolute value of x is less than c. So, and I'll kind of, we don't need this until later, so I'll kind of jot it up there. So x is between negative c and c. Okay. Which in terms of our numbers here, that's going to mean that 3x plus 4 is between negative 5 and 5. Okay. So now to solve for x, right, as long as I'm not dividing or multiplying by a negative, I can just treat them as equal signs as long as I just work with all 3 regions, right? So first thing, if I'm solving for x, I need to subtract 4 from both sides. So I'm going to do that. Negative 5 minus 4 is less than 3x. Notice that I'm not showing as much work, right? Eventually I'll just be doing it as I normally would, right? And so here I would probably show the minus 4 on both sides, but here the whole goal was to just get 3x on its own. So now I don't need to write the plus 4 minus 4. So I have negative 5 minus 4 is negative 9, which is less than 3x, which is less than 5 minus 4, which is 1. Then to get x on its own, I just need to divide both sides by 3, right? So I have negative 9 over 3, and 3 is positive, so I don't have to switch the signs. So I have negative 9 over 3 is less than x, which is less than 1 over 3. Okay. Negative 9 over 3 is just negative 3, right? 1 over 3 isn't going to simplify. So what I'll do is I'll have x is between negative 3 and 1 over 3. And I can't remember. Let me just go see here. Oh. Where is it gonna? It's gonna make me go back there. And now it's gonna be different numbers. Come on. That's okay. I just wanted to check it, but that's all right. Just ignore that. So then our interval is from negative 3 to 1/3. So, but not including those endpoints, right? So the answer in interval notation is from negative 3 to 1 over 3. I just couldn't remember if they wanted the decimal. It should always accept the exact answer, but sometimes if it says to, round it to 3 decimal places, but I just couldn't remember if it was using the fraction or not. but it should say round to, 4 decimal places if it wants the rounded value. Otherwise, just use the exact answer. All right, good. That's 35. How about 36? Bring this down. Question 36 was the absolute value of 3x minus 2, which is greater than or equal to 5. Just to give you a taste of either situation. This, just kind of off the top of my head, looks like the absolute value of x is greater than or equal to c. So I need to figure out what the equivalent form of this is. The absolute value of x greater than or equal to c. That's this situation, right? The fourth situation. So then x is less than or equal to negative c, or c is less than or equal to x. Okay. So x is less than or equal to negative c, or c is less than or equal to x. Let me just confirm that, because actually I have it here, so I should just be looking here. Good, I got it. I don't trust my memory, not for a second. So what I have is I'm going to need to solve 2 individual inequalities, right? But I'm going to find restrictions on x. Okay, so this is the same as the absolute value of 3x minus 2 is less than or equal to negative 5, or 5 is less than or equal to the absolute, or sorry, I can ditch these absolute value brackets. 3x minus 2, because that was the whole point of finding the equivalent form. I was crammed. Okay, I'm going to solve these side by side just to save a little bit of paper here, or fake paper. 3x minus 2 is less than or equal to negative 5, or 5 is less than or equal to 3x minus 2. So I'm just jotting down what I need to solve. So here I get 3x is less than or equal to negative 5 plus 2. So then 3x is less than or equal to negative 3. So x is less than or equal to negative 1, right? Negative 3 over 3. Same thing on this side, right? If I'm solving for x, I need to get x on its own. So 5 plus 2 is less than or equal to 3x. So 7 is less than or equal to 3x. So 7 over 3 is less than or equal to x. And notice I'm not multiplying or dividing by a negative number, so I'm safe. Okay. So in terms of our interval, right, x has to be less than or equal to negative 1, and then x has to be greater than, right, even though it's facing, but 7 over 3 has to be less than or equal to x, but it's easier to just read it as x has to be greater than or equal to 7 over 3. Sometimes mapping it to the number line first might be easier, right, because it's easier to map from these inequalities to the number line and then take the number line to your interval notation. But at the end of the day, your interval notation answer should be from negative infinity to negative 1, and then pick right back up at, oh, and it's including negative 1, sorry, including those endpoints, 7 over 3 to infinity. Nice. Okay. There. That's the end of inequalities. right? We'll save lines for our next test, so we'll save it for after a reading break. Do you have any questions that you want to go through from the practice test, right? If it's not on the practice test, it definitely won't be on the test. So 35 over x minus, okay, I'll try to, do you know what number that is? Looks like, should be one of these. Oh, is equal to 0. Equal to some number. Just so I know which one we're doing here. Oh, on the last assignment. Okay. So it's not from the practice test, but you want to go through 35 over x minus 42 over x minus 1 plus 2 equals 0. I'm assuming that this is the setup. Is that correct? Okay. So what you need to do is you need to find a common denominator. And there is a similar question to this one on the practice test as well. I just couldn't find it. So you need to have a common denominator. I'm going to force the common denominator to be x times x minus 1. Okay. You can do it just on the left-hand side, or you can go all the way through. It doesn't actually matter. But so what you have is you have 35 over x. If I need to force it to be over x times x minus 1, then here I need to multiply by x minus 1 over x minus 1. Minus 42 over x minus 1. But if I need a common denominator of x times x minus 1, I need to multiply this term by x, right? Which means I really need to multiply by x over x. Then for the last term, it's not over anything, but I need to force it over this common denominator of x times x minus 1. So what I need to do is I need to multiply this by x times x minus 1. And like I said, you can do this for just the left-hand side, or I mean, in theory, it doesn't change anything because 0 times x minus 1 over x times x minus 1 is just 0, right? So I'm just not gonna bother with that one. And I'll try to stack my equal signs here. Okay. So what I can do is I can expand the numerators and simplify, right, putting it all over this common denominator. So what I have is I have, I'll expand it out. Yeah. 35 x minus